I am Nicolzam Gidolas Reyes from BSE 2B. I am here recording this video again to discuss to you how I solved the assignment number 6. The problem in assignment number 6 is referring to figure 2. Change RA to 0.2 ohms, RB to 0.3 ohms, and RL to 0.5 ohms with the same battery polarities, and with EA is equals to 24 volts and EB is equals to 26 volts as shown. Calculate A, current IL, IA, and IB, B, the load voltage VL, C, the load and battery power PL, PA, and PB using Thevenin's theorem. So, given there are two voltage sources, EA is equals to 24 volts, EB is equals to 26 volts, and connected to resistor RA is equals to 0.2 ohms with current A, RB is equals to 0.3 ohms, current B, RL is equals to 0.5 ohms which has current L. So, Thevenin theorem is a resistor of R ohms be connected between any two terminals of a linear network. The resulting steady-state current through the resistor is the ratio of the potential difference between the 2 points prior to the connection and the sum of values of the resistance R theta, resistance between 2 points and connected to resistance R. So, in step 1, open circuit RL, then apply loop current along circuit. So, the loop current direction is in clockwise direction. Now, to solve, we use or apply KVL. So, positive 24 minus terminals current times 0.2 plus 0.3 minus 26 is equals to 0. Then 24 minus the total of RA and RB is equals to 0.5. Terminals current minus 26 is equals to 0. Then transpose 26 minus 24 is equals to negative 2 is equals to 0.5 ITH, or the current terminals current. So, divide both sides by 0.5 to cancel 0.5. Then, the terminals current is equals to negative 4 amps. Now, so it means that the assigned loop current direction is in opposite direction, which is counterclockwise directions. Now, compute the terminals voltage. So, it is equals to positive 26 minus terminals current multiplied by 0.3. Now, 26 minus negative 4 times 0.3, it is equals to 26 minus 6 over 5. Now, terminals voltage is equals to 124 over 5 volts. Now, step 2. So, step 2. Compute terminals resistance, short circuit all independent source, and open circuit all independent current sources. So, short circuit all the voltage source EA and DB, short circuited. Then open circuit all the current sources. So to compute or to solve the terminals resistance, we can use the formula of terminals resistance is equals to R1 times R2 over R1 plus R2. So substitute the value 0.2 times 0.3 over 0.2 plus 0.3. So terminals resistance is equals to 3 over 25 ohms. Now let's solve for step 3. So let's go to step 3. So in step 3, construct the Thevenin's equivalent circuit and solve resulting currents. So the terminal circuits of the following diagram is the terminal voltage is equals to 124 over 5 volts and terminal resistance is equal to 0.3 ohms and RL is equals to 0.5 ohms. Now to compute IL, it is equals to EO or the terminals voltage over terminals resistance plus RL. So substitute the value 124 over 5 over 3 over 25 plus 0.5. We will get IL is equals to 40 amp. Now since we know how to solve VL, since we have the value of our RL, we can solve VL. VL is equals to IL times RL. Then substitute the value 40 times 0.5. It is equals to 20 volts. So VL is equals to 20 volts. Then since we can also now solve for PL. PL is equals to IL times VL. Then substitute the value 40 times 20. It is equals to 800 watts. So PL is equals to 800 watts. Now let's go solve for IA. So repeat the same process. So first open circuit RA. So solve terminals. So since resistor RA is open, 24 volts will become 0 since there are no lines connected to this loop. So formula in getting IT or the current total, it is equals to EB over RB plus RL. Substitute the value 26 over 0.3 plus 0.5. IT is equals to 65 over 2. Then let's solve. Then IT is equals to V minus VB over RB. Then substitute value. Since we have the value of our IT, now let's have solve for BB. So IT is equals to 65 over 2 equals V. Since we are solving this one, so 26 minus VV over 0.3. So cross multiply 0.3 times 65 over 2 is equals to 26 minus VB. Then solve 9.75 VB is equals to 26 minus VB. Then transpose VB to other side, then 9.75 to other side. So we have the equation VV is equals to 26 minus 9.75. So VB is equals to 16.25 volts. Now let's solve for terminal resistance here. So to solve terminal resistance is equals to RB times RL over RB plus RL. So substitute the values 0.3 times 0.5 over 0.3 plus 0.5. Terminal resistance is equals to 3 over 16 ohms. Now we can solve IA. So EO is equals to 16.25 and terminal resistance is equals to 3 over 16. Then our RA is equals to 0.2 ohms. So to solve IA, this IA is equals to EO over RO plus RA. Then substitute the value 16.25 over 3 over 16 plus 0.2. IA is equals to 20 amps. And now let's solve for PA. So to solve PA, it is equals to VA times IA. So substitute the value 24 times 20. PA is equals to 480 watts. Now to solve IB, let's solve it by using the KCL. IA plus IB minus IL is equals to 0. Then we have equation IB is equals to negative IA plus IL. So IB is equals to negative IA plus IL. Then substitute the value negative 20 plus 40. IB is equals to 20 amps. Now to solve PB, it is equals to PB is equals to VB minus times IB. So substitute the value 26 times 20. Now PB is equals to 520 watts.